Okay, I think we are live. Yeah, last time I had a problem with the chat. It stopped showing me messages on the iPad for some reason. Twitch Stream Manager. So I will try to check. It's in browser as well, so not sure yet how to fix the chat problem, but yeah, I will find out someday. Anyways, so we finished generic data type section yesterday on previous stream, and today the excited topic traits. Traits is defining shared behavior. So if you watch any video on YouTube about Rust, it's traits are everywhere in Rust, and finally I will learn about it. So yeah, let's start. Right. So trait defines functionality a particular type has and can share with other types. We can use traits to define shared behavior in abstract way. We can use trait bound to specify that generic type can be any type that has certain behavior. Now, traits are similar to a feature often called interfaces in other languages, also with some differences. Okay, so this is kind of interfaces, but in Rust, and their own specific. So defining a trait. A type's behavior consists of methods we can call on the type. Different types share the same behavior if we can call the same method on all of those types. Trait definitions are a way to group methods signature together to define set of behaviors necessary to accomplish some purpose. Alright, so different types share same behavior, but only if we can call same method on all those types. So trait definitions aware group signature together to define the behavior necessary to accomplish some purpose. Okay, not yet clear. So let's continue. For example, let's say we have multiple structs that hold various kinds and amounts of text. A new article struct that holds a new story field in particular location, and a tweet that can have at most 2080 characters along with metadata that indicates whether it has a new tweet, a retweet, or a reply to another tweet. We want to make a media aggregator library, create name aggregator, that can display summaries of data that might be stored in new article or tweet instance. To do this, we need a summary from each type, and we'll request that summary by calling a summarize method on an instance. List intent 12 show the definition of public summary. Public summary trait that express this behavior. So yeah, to initiate trait, we need trait keyword, pub trait, summary function, summarize, take self, and return string. All right. Yeah, it basically looks like an interface. So we have like declaration of the function. This is, yeah, clear. So here we declare a trait using a trait keyword and then the trait's name, which is summary. In this case, we also declare the trait as pub, so that crate, depending on this crate, can make use of this trait too. As we'll see in a few examples, inside the curly brackets, we declare the method signature that describe the behavior of types that implement this trait, which in this case is function summarize. Yeah. Okay. After the method signature, instead of providing an implementation within curly brackets, we use a semicolon. Yeah. Here we are, semicolon. Each type of implementing this trait must provide its own custom behavior for the body of the method. The compiler will enforce that any type that has the summary trait will have the method summarize defined with this signature exactly. Okay. Yeah, so far definitely something like interface. A trait can have multiple methods in its body. The method signature are listed one per line and each line ends in a semicolon. All right. So this is something interesting. Implemented a trait on a type. So yeah, let's quickly jump and create new project, cargo new, what it be, traits 10. All right. Okay. So now that we've defined the desired signature of the summary that traits methods, we can implement it on the types in our media aggregator. Listing 1013 shows an implementation of the summary trait on new articles track that uses the headline, the author, and the location to create the return value of summarize. For the tweet struct, we define summarize as the username followed by the entire text of the tweet. Assuming that tweet contains is only limited to 280 characters. So yeah, let's just, I don't know, maybe just copy. So now we need the summary trait. So can I just do it myself? Trait summary and fn. Yeah, as we can see here, it should be basically the same, and with semicolon and end. Let's try to build it. Yeah, no errors so far. So let's take a look. Here is we define our trait, the EG interface. So we have public struct new article, which basically have string fields, headline, location, author, content, yeah, and we implement summary or trait for our struct new article. So summarize function, and what we do here, we just, yeah, we use a macro format. What did it actually do? I forgot. Create a string user interpolation of runtime expression. So we'll return the string like if I do a news article, yeah, maybe need to create some struct. Let news article location, author, content, all right. So I guess we will see the username and content. So news article headline by author, location. Oh, sorry, I'm looking on different implementation. It's for tweet, but for a news article. So it takes headline, then it shows by author and location in the brackets. Okay. Okay, but here news article. Oh, this has come from here. So I think now it should be, yeah, clearer. So headline, comma by author location. Yeah, exactly. So, and for the tweet, just username and content. Makes sense. Let's quickly edit as well. So and quickly run it as well. I forgot to save the file, so card run. Yeah, username content. Hello world tweet. Yeah, now it's, yeah, more pleasant to me. Looks much better. So anyway, implementing a trait on a type is similar to implementing a regular methods. The difference is that after implementation, we put the trait name we want to implement, then use the for keyword, and then specify the name of the type we want to implement the trait for. Within the implement block, we put the method signature that the trait definition has defined. Instead of adding a semicolon after each signature, we use curly brackets and fill in the method body with specific behaviors that we want methods of the trait to have for the particular type. Now that the library has implemented the summary trait on use article and tweet, user of the crate can call the trait method on instances of news article and tweet in the same way we call regular methods. The only difference is that the user must bring the trait into scope as well as types. Okay. So must bring the trait into scope as well. Yeah, this is clear, so definitely. Here is an example of how a binary crate could use our aggregator library crate. So yeah, this is maybe a good point to practice the module. So can I just create aggregator REST file, then put everything here, use I think I need to specify mod aggregator like this. Okay, it's still working, but do I need summary here? Okay, yeah. See, if we do not import summary, we will not have this summarize method. This is, yeah, basically clear. So yeah, the only difference is that the user must bring the trait into scope as well. Exactly what we did with the summary. Good. So we have that. Can continue. This code print one new tweet, horse, books, of course, as you probably already know, people. Yeah, the content and the username. Other create that depend on the aggregator create can also bring the summary trait into scope to implement summary on their own types. One restriction to note is that we can implement a trait on a type only if at least one of the trait or the type is local to our crate. Yeah, let me think about it 1 second. So we can implement trait on a type only if at least one of the trait or the type is local to our crate. So if we, let's say we imported some crate, we imported some trait and imported some struct, and then we cannot implement it here, like implement summary for article is not allowed, right? Or no? If we, for example, hide it, can we do it like this still? Yeah, no problem. So does it mean it's local? Summary and new article for this grade. Don't really get it, actually. Okay, maybe we will find out it from the text. For example, we can implement standard library traits like display on a custom type like tweet as part of our aggregator crate functionality because the type tweet is local to our aggregator crate. Okay. We can also implement summary on vector in our aggregator crate because the trait summary is local to our aggregator trait. Okay, but what we can't do? But we can't implement external trait on external types. For example, we can't implement the display trait on a vector within our aggregator crate because display and vector are both defined in the standard library and aren't local to our aggregator crate. This restriction is part of property called coherence. Okay, and more specifically the orphan rule. So name because the parent type is not present. This rule ensures that other people's code can break your code and vice versa. Within the rule, two crates could implement the same trait for the same type. Okay, yeah, makes sense. And Rust wouldn't know which implementation to use. Yeah, this is definitely makes some sense because once you update the library, you may have different implementation for the trait from the library which wasn't there before, and this is can make it can lead to this situation described here when have two implementation but Rust will not know which one to use. Okay, default implementations. Sometimes it's useful to have default behavior for some or all of the method in trait instead of requiring implementation for all methods on every type. Then as we implement the trait on a particular type, we can keep or override each method default behavior. Okay. Listing 1014, we specify a default string for the summarize method of the summary trait instead of only defining the method signature as we did in listing 1012. So yeah, let's do this. Let's back our implementation here and remove this one. And maybe let's actually no, let's left it as is for now and see what we have next. To use default implementation to summarize instance of new article, we specify an empty implementation block with implementation summary for news article. So cargo run, and you see we have read more for the news article default implementation, and we can do same for the tweet and do run, and you see if the implementation not some specific for the type, we can have the implementation for it and default, and yeah, this is basically a nice one. So even so, we no longer defining the summarize method on your article directly. We've provided a default implementation and specify that news article implement the summary trait. As a result, we can still call the summarize method on an instance of news article like this. Yeah. This code prints new article available, read more. Creating default implementation doesn't require us to change anything about implementation of summary on a tweet. In listing 1013, the reason is that the syntax for overriding a default implementation is the same as syntax for implementing a trait method that doesn't have a default implementation. Sorry, the reason is the syntax. Oh, yeah, sorry, got it. So, creating default implementation doesn't require us to change anything. This is the reason. Okay, so default implementation can call other methods in the same trait even if those other methods don't have default implementation. In this way, a trait can provide a lot of useful functionality and only require implementers to specify a small part of it. Okay, for example, we could define the summary trait to have a summarize author method whose implementation is required, and then define a summarize method that has a default implementation that called the summarize author method. This is actually interesting. Let's try to add one. So summarize author reference self return string no implementation, and self summarize author. Okay, let's use format here instead. And now to make it work, we need implement summarize author. I kind of like it what I'm seeing here. To use this version of summary, we only need to define summarize author when we implement the trait on a type. Yeah, exactly. Just what we did. After we define summarize author, we can call summarize on instances of the tweet struct, and the default implementation of summarize will call the definition of the summarize author that we've provided. Because we implemented summarize author, the summary trait has given us the behavior of the summarize method without requiring us to write any more code. Yep. Okay. Note that it isn't possible to call the default implementation from an overriding implementation of the same method. Okay, it's impossible to call default implementation from an overriding implementation. So, as I understand, if we do it like this, it will not use default implementation and use this one. Yeah, exactly. Okay, traits as a parameters. Now that you know how to define and implement traits, we can explore how to use traits to define functions that accept many different types. We'll use the summary trait we implemented on the news article and the tweet types in list 1013 to define and notify function that call the summarize method on its item parameter, which is of some type that implements the summary trait. To do this, we use the implementation trait syntax like this. Okay. Not sure it's part of aggregator. Yeah, it should be because it uses the summary, so it might be. or might not. Let's move it for the main for now. So tweet, sorry, yeah, we can notify tweet sorry, cargo run. Yeah, I think we are good here. Just want to make sure my chat is fine. Okay, so we used notify, and yeah, to demonstrate we can use different types. Here we can also put use. There is a typo. So we create a function for different types for tweet and use article. Instead of concrete type of the item parameter, we specify the implementation keyword. Okay, yeah. Here's the implementation keyword, which is something new in function params for us. And the trait name. This parameter accepts any type of the implementation that specifies trait. In the body of notify, we can call any method on item that come from the summary trait, such as summarize. We can call notify and pass in any instance of news, article, or tweet. Code that calls the function with any other types, such as string or an I32. So yeah, code that calls the function with any other type such as string and or I32 won't compile because those types don't implement summary. Yeah, this is one is kind of clear. Traits bound syntax. Okay. The implementation trait syntax works for straightforward cases, but is actually syntax sugar for a longer form known as trait bound. It looks like this. Okay, so we can use generic like t type summary, and here okay, and it was like this. Okay, yeah, just let's run to make sure it works. This longer form, sorry, No, it's not related to our stream, I guess. Yeah. This longer form is equivalent to the example in the previous section, but is more verbose. We place the trade bounds with the declaration of the generic type parameter after a colon and inside angle brackets. All right. This implementation trade syntax is convenient and makes for more concise code in simple cases, while the fuller trade-bound syntax can express more complexity in other cases. For example, we can have two parameters that implement summary. Doing so with the implementation trade syntax look like this. Yeah, and this form is much better in this case. So using implement trade is appropriate if we want this function to allow item 1 and item 2 to have different types as long as both types implement summary. If we want to force both parameters to have the same type, however, we must use a trade bound like this. Yeah, much nicer. The generic type T specify as the type of the item 1 and item 2 parameters constrain the function such that the concrete type of the value passed as an argument for item 1 and item must be same. Okay. Specifying multiple trade bounds with the plus syntax. Oh. Yeah, we can try this one. I guess we can plus display from FMT probably. Can we quickly fix it? Is it? No, probably like this. No, I think I'm doing something completely wrong. Yeah, I messed up. I derived debug. It's not about display. But yeah, basically I can edit. With the two trace bound specified, the body of notify can call summarize and use for the format item. Okay. Clear trade bounds with where clauses. Using too many trade bounds has its downsides. Each generic has its own trade bounds, so functions with multiple generic type parameters can contain lots of trade bound information between the function name and its parameter list, making the function signature hard to read. For this reason, Rust has alternative syntax for specifying trade bounds inside where clause after the function signature. So instead of writing this, oh, actually, we saw it once already. The our NeoVim editor code action bring this syntax for us once. So yeah, instead of define t and u bounds right away, we can move it to where instead. So basically we can do I need return, or I can just write where t summary? Is it fine? Yeah, we are good here. So we moved clarification on the where after the where keyword. And we can do multiple with comma like this. All right. This function signature is less cluttered. Yeah. The function name, parameter list, and return type are close together, similar to a function without loss of trait bounds. So return a type that implement traits. Okay. So we can return implementation of summary, and I guess we can do same trick with generic here as well. So we can make let's quickly try it before even reading what it says. And let's try experiment no. But yeah, there is no multiple return types, so maybe it makes sense. Yeah, it makes sense to not use generic here, but let's see. We can also use implement trait syntax in the return position to return a value of some type that implements a trait as shown here. By using implement summary for the return type, we specify that the return summarizable function returns some type that implement the summary trait without naming the concrete type. In this case, return summarizable returns a tweet, but the code calling this function doesn't need to know that. The ability to specify return type only by the trait it implements is especially useful in the context of closure and iterators, which we cover in chapter 13. Closures and iterators create types that only the compiler knows, or types that are very long to specify. The implementation trait syntax let you concisely specify that a function returns some type that implements the iterator trait without needing to write out a very long type. Yeah, that's for sure. However, you can only use implement trait if you return a single type. For example, this code that returns either news, article, or tweet with return type specified as implementations. Simple summary wouldn't work. Okay, let's take a look why it will not work. So if switch news article is returned, else tweet is returned. Oh, if you return a single type. So this is two types. Even if they implemented summary, we can do this. It should be both times either tweet or news article. Returning either a news article or tweet isn't allowed due to restriction around how the implementation trait syntax is implemented in the compiler. We'll cover how to write a function with this behavior in the using trait object that allow for values of different types section of chapter 17. Yeah, it's close to the end of the book. Not there yet, but we are in the equator, I guess. We're doing good so far, and we already gained a lot of knowledge from the book, and we can understand more. Like, for example, I'm watching some videos about the Rust on YouTube, and some pieces I already can understand because I'm familiar from the book, but some is still not. For example, it was about the trade, but now we already understand what is a trade, and yeah, let's just finish this section. Using trade bounds to conditionally implement methods. By using trade bound with an implementation block that uses generic type parameters, we can implement method conditionally for type that implement the specified traits. Okay, for example, type pair list in 10.15 always implement the new function to return new instance of pair. Recall from defining method chapter 5. So what is new here? Not sure what it references to, but yeah. Oh, so to the self alias is type alias for the type of implementation block, which in this case is pair t. But in the next implementation block, pair t only implements the CMP display method if its inner type t implement the partial OR trait that enable comparison and display trait that enables printing. Okay, let's take a look in the code snippet. What's going on here? So we have struct pair with x and y generic type. Then we have new to be able to create pair. And we have implementation of pair, which bounds us to display and partial OR. So it bounds, I think it bounds CMP display function use only for the types that implement display and partial ORs. Yeah, I think so. Let's, I don't know, let's create another module, copy this snippet, and maybe what we can use here, we can use vector and I don't know, some string, and let's have pair. And the question is, okay, it's already complain. Pair. Oh, it should be the same type. Yeah, my bad. So new is private, so like to make it public, I guess. Okay, need to make public the new. It's private struct, so we need to make it public, I guess. Might show the error mode one. Oh, And what I would like to know if we can do CMP display. First of all, it should be public. And let's run it. The largest number is y hello world 1. What if we do something like this? It also works, but what if we try some custom types? I guess we still can do tweet and tweet 1. No method CMP display on method pair tweet. So this is particular method is not available, but we still can use it in the new, because there is no bounds of this new function. The bounds only of for implementation of this piece of function which are here in CMP display. In any other functions we will write here. Okay, I think this is the clear. So we can also conditionally implement a trait for any type that implements another trait. Implementations of a trait on any type that satisfies the trait bounds are called blanket. Let's do it one more time. Implementation of a trait on any type. Okay. Trait on any type that satisfies the trait bounds are called blanket. Blanket implementation, sorry, and are extremely used in the Rust standard library. For example, the standard library implements the toString trait on any type that implement the display trait. The implementation block in the standard library looks similar to the code. So implement the display to string. Okay. To string. So we did in aggregator implement summary. Here's implement generic. Bounds to display, generic bounded to display. To string for t. Don't completely get the syntax. To string for t. Let's paste it here in our code. Import display. Type parameter t must be used as the type parameter for some local type. Okay, cargo build. Sorry, cargo build. So this is not working. Because we don't have to string, I guess. So we need struct to string. Maybe not struct, but rate. Or struct. Okay, so it expected trait and okay, now I get it. Or yeah, like this. So we implement trend to generic, and this is called blanket implementation. I think we can do self what is display? Oh, display allow us to no. Okay, I think it's more or less clear. And yeah, nothing in the chat. So because the standard library has this blanket implementation, we can call the toString method definition by the toString trait on any type that implements the display trait. So this is basically implemented in the standard library. For example, we can turn integers into their corresponding string values like this because integers implement display. Okay. Okay. Blanket implementation appear in documentation for the trait in the implementers section. Okay. Traits and trait bound let us write code that uses generic type parameter to reduce duplication, but also specify the compiler that we want the generic type to have particular behavior. The compiler can then use the trait bound information to check. Yeah, sorry, was distracted. Trait and trait bound let us write code that uses generic type parameter to reduce duplication, but also specify to compiler that we want the generic type to have particular behavior. The compiler can then use the trait bound information to check that all the concrete types used with our code provide the correct behavior. In dynamically typed languages, we would get an error at runtime if we called a method on a type which didn't define the method, but Rust moved those errors to compile time, so we're forced to fix the problem before our code is even able to run. Additionally, we don't have to write code that checks for behavior at runtime because we've already checked at compile time. Doing so improves performance without having to give up the flexibility of generics. So yeah, as usually, Rust doing in the compile time prevent us from the problems. So traits was the interesting section we've done today, and maybe let's do a bit of Rustlings as we're doing on last streams. So let me change layout on the camera, put it here, and we stop at the string. So yeah, last time I think I found out that Copilot do a lot of stuff for me, so maybe I just need to Copilot stop. It's deprecated, use Copilot disable. Copilot disable. And let's try to do exercise for strings. So the error on the line 12, not 12, but 13, and there expected struct string found str. So yeah, this one is the easy one. Next, error on the line 9. Expected reference like string slice found struct. All right. Remove white spaces from both ends of string. Do we have for some reason there is no LSP auto-completion as well. So let's try to use Rust docs. And no. So remove removes a char from the string at a byte position and return it. No. Remove matches. Remove all matches of pattern path in string. I think we can try this one. Oh. There is a method with similar name matches. No method name remove matches. This call modifies its receiver in place. Probably want to use this value after calling the method. Okay. The let output will be input to string, then output and output. Use of unstable library feature string remove matches new API. Okay. Is it marked here as new API? Why it's a problem? Maybe we need something like trim. Okay, trim. Return a string slice with leading and trailing white space removed. Okay. Input trim. Mismatch types to string. Okay, cool, we solved it. Compose me add wall to the string. There is multiple ways to do this. So let mat output stir to string output push. Oh no, I just will use format. And so vault yeah. Such a nice error which tell you are doing things wrong. Expected value found built-in type str. Oh yeah, as usually I messed up with the variable name. And replace me. Replace cars in the string with balloons. So input replace cars balloons to string. Yoo-hoo, we've done it. Okay, here are a bunch of values. Some are strings, some are slice of strings. Your task is to call one of those two functions on each value, depending on what you think each value is. What is at either string slice or string slice or string before the parentheses on each line. If you're right, it will compile. No hint this time. We are not using hints anyway. So this is string slice. This is string, obviously. String to own it. What is to own it? Looks like it's string. Into. I don't know what is into, but yeah. Format is string. It's a string slice. Trim. String slice. To string replace. Get string. Don't know, but let's try string. Okay. First try. And the next is modulus. Yeah, I think I will left modulus to the next time. Don't want to do it today. So thank you everyone for watching. We'll see you the next time.